Welcome back to AI Podcast. Yesterday we heard about Willow and fundamentals of quantum computing.
Right.
Today we're going to explore
Yeah.
how Willow could supercharge AI.
It really is. It's a really exciting intersection of two cutting-edge fields,
For sure.
both pushing the boundaries of what's possible.
Okay, so Willow is a quantum computing platform.
Yes,
But it's not meant to replace the computers we use every day, right?
exactly. Think of it more as like a partnership.
Okay.
Classical computing is great for many tasks, but it struggles with certain kinds of complexity.
Okay.
And that's where quantum computing steps in. It offers a turbo boost
I see.
to specific areas where classical computers hit a wall.
So it's more like a dynamic duo,
Precisely.
each playing to their strengths.
And Willow is designed to seamlessly integrate these two worlds,
Okay.
kind of like a bridge between them.
That makes a lot of sense. So where does this dynamic duo really shine in the world of AI?
There are 6 key areas where Willow can make a significant difference.
Okay.
Speeding up machine learning algorithms,
Okay.
solving complex optimization problems, improving neural network training,
Got it.
enabling faster data analysis,
Okay.
enhancing decision-making models, and expanding AI capabilities through hybrid models.
Wow. 6 key areas. That's a lot to unpack.
Yes, it is.
Let's start with speeding up machine learning algorithms.
Sure.
How does Willow do that?
So machine learning involves a lot of heavy lifting computationally, like training AI models on massive data sets. Even on powerful computers, this can take a lot of time.
Okay.
Quantum algorithms, however, can significantly reduce that runtime.
So it's like a shortcut.
That's a great analogy.
It allows AI systems to learn much faster.
Imagine a financial institution using AI to assess customer credit risk.
Right.
They have huge data sets with tons of data points for each customer. Income, transaction history, credit score, and more. So for a classical computer, sifting through all that to build a reliable model would take a significant amount of time.
Sure.
But Willow's quantum algorithms can analyze that same data set potentially in real time,
Wow.
giving the financial institution a major edge in decision-making.
Okay.
And this applies to other areas too, like in healthcare, where we might analyze vast genomic data sets much faster to personalize treatments or predict diseases earlier.
That's impressive.
Yeah.
You mentioned that Willow also excels in solving complex optimization problems.
Yes.
What does that mean exactly?
Optimization problems are everywhere in AI,
Okay.
and they often involve finding the best solution out of a huge number of possibilities. Imagine trying to optimize a logistics network with thousands of trucks, different routes, schedules, and capacities.
Yeah.
Or even optimizing control systems for a fleet of autonomous drones for efficient and safe deliveries.
I can see how those would be incredibly difficult problems to solve.
Right.
Even with our most powerful computers today.
Yes. And as the number of variables grows, traditional algorithms can struggle with something called combinatorial explosion.
Combinatorial explosion.
Yes.
Okay.
Where the number of possible solutions explodes. Quantum algorithms, like the Quantum Approximate Optimization Algorithm, QAOA, offer a clever way around this.
So instead of brute forcing through every possibility,
Right.
they use quantum properties to find the best solution faster.
That's a great way to put it. Let's go back to our ride-sharing example.
Okay.
Imagine a company like Uber using AI to optimize its operations in a busy city.
Okay.
They need to consider traffic, driver availability, rider demand, countless other factors for efficient pickups, minimal wait times, reduced fuel consumption.
Right.
It's a massively complex optimization problem.
I can imagine a classical computer would really struggle, especially as the city grows.
Absolutely. But with Willow, they could use quantum algorithms to solve this much faster and with greater accuracy.
Wow.
Imagine rerouting drivers on the fly based on real-time traffic and demand, all while minimizing fuel use and ensuring quick arrivals for riders.
That's a win-win for everyone.
Yes.
And it hints at a more sustainable transportation system as well.
Exactly.
Okay, so we've covered speeding up machine learning and solving those complex optimization problems.
Yeah.
What about neural networks? How does Willow enhance those?
Neural networks are like the brains behind many AI systems.
Okay.
They excel at tasks like image recognition and natural language processing. But training these networks, especially deep ones with many layers,
Right.
can be incredibly computationally intensive.
Why is that? What makes training them so demanding?
It comes down to the sheer number of calculations involved.
Okay.
Training involves constantly adjusting millions, sometimes billions of parameters,
Wow.
and this process requires a huge number of matrix multiplications and
Hmm.
other complex calculations.
Right.
On classical computers, this can take days, weeks, or even months.
But with Willow's quantum capabilities, we could speed this up significantly.
Yes, by leveraging quantum linear algebra.
Okay.
Imagine training a model like GPT-3 not in weeks, but in days or even hours.
Wow.
That's the potential. And Willow supports the development of hybrid quantum classical models,
Okay.
where computationally intensive parts of training are handled by Willow, while others are handled by classical computers.
So each system does what it's best at. That's fascinating.
Exactly.
You also mentioned faster data analysis as an area where Willow excels.
Yes.
Can you tell me more about that?
Sure. We live in a world overflowing with data,
Yeah.
and AI systems need that data to learn and make predictions.
Right.
But processing and analyzing this data, especially as data sets grow larger and more complex, can be incredibly time-consuming,
Right.
even with the most powerful classical computers.
It's like searching for a needle in a haystack, but on a massive scale.
Exactly. Quantum algorithms like the quantum Fourier transform QFT are incredibly good at specific data analysis tasks.
Okay.
They can speed up things like finding patterns in data and reducing dimensionality, which means simplifying data without losing critical information.
So it's like having a superpowered tool that helps us make sense of vast amounts of data much faster.
Think about a medical AI system analyzing genomic data to find disease patterns.
Okay.
Genomic data is incredibly complex.
Yeah.
Analyzing it to find subtle patterns is computationally challenging.
Yeah. I can only imagine the amount of data involved in analyzing someone's entire genome.
But with Willow, we could potentially process and analyze this data much faster,
Wow.
enabling researchers to identify disease biomarkers,
Yeah.
personalize treatments, and develop new drugs more quickly.
That's incredible. It sounds like Willow could truly revolutionize healthcare research.
It definitely has the potential, and this is just one example. Think about financial markets, where analyzing real-time trading data to identify trends and anomalies faster could be game-changing. Or imagine analyzing satellite imagery to track deforestation or monitor climate change with incredible speed and detail.
This is really exciting. We've covered 4 key areas so far.
Yes.
Speeding up machine learning,
Right.
solving those complex optimization problems, improving neural network training,
Yes.
and enabling faster data analysis.
Exactly.
We still have 2 more areas to explore.
Yes, we do.
You mentioned enhancing decision-making models. What exactly does that mean in the context of AI?
So think about all the areas where AI is being used to make critical decisions, like finance, healthcare, transportation. These systems need to weigh different options, assess risks, and ultimately recommend the best course of action. But traditional decision-making models can sometimes struggle, especially in dynamic environments where things change quickly.
I can imagine that's a challenge. Can you give me an example?
Sure. Imagine a financial AI advising on investment strategies.
Okay.
The system has to consider market trends, risk tolerance, and investment goals to recommend the best allocation of assets.
Right.
Traditionally, this involves running simulations,
Mm-hmm.
which can be slow and limited in their scope.
So how does Willow change things?
With Willow's quantum capabilities, we could run thousands, even millions of simulations in parallel.
Wow. Exploring a much wider range of possibilities. This allows the AI system to make more informed and robust decisions.
That's a huge advantage, especially in a fast-paced field like finance. But it also makes me think about the potential ethical implications of relying on AI for these kinds of decisions. How do we ensure fairness and transparency in these systems?
You raise a very important point. As AI systems become more sophisticated, it's crucial to consider the ethical implications. We need to ensure that these systems are designed with fairness and transparency in mind,
Right.
and that there's human oversight in the decision-making process.
Absolutely. We need to be careful not to blindly trust algorithms, especially when it comes to high-stakes decisions. Okay, the last key area we need to discuss is expanding AI capabilities with hybrid models. Can you explain what those are?
Hybrid models are a way to combine the strengths of both quantum and classical computers.
Okay.
It's about recognizing that quantum computers aren't meant to replace classical computers entirely, but to work alongside them, tackling the tasks they're best suited for.
It sounds like a powerful synergy. Exactly. For example, a weather prediction AI could utilize Willow's quantum capabilities for simulating complex atmospheric conditions while relying on classical models for things like integrating historical data. Or imagine a medical AI that uses quantum computing to analyze complex medical images while using classical computing to process patient records and medical history.
It's like assembling a team of experts, each with their own unique skills to solve a complex problem.
That's a great analogy. And Willow is designed to support this hybrid approach,
Yeah.
making it easier for developers to integrate quantum computing into existing AI systems.
It's not just about building completely new systems, but also about enhancing the ones we already have.
Exactly.
That's really interesting. We've covered a lot of ground in terms of how Willow can enhance AI in various ways.
We also
But
need
I'm
to
curious.
think carefully about the ethical implications of these technologies and ensure that they are used responsibly and for the benefit of society as a whole.
Absolutely.
Yeah.
As AI becomes more powerful,
Huh.
we need to make sure
Yeah.
it's guided by human values and ethics.
Right.
I agree, and I think that's a good reminder that technology is a tool, and it's up to us to
Absolutely.
use it wisely.
Right.
Well, it has been an incredibly fascinating deep dive.
It has.
You've explored the fundamentals of quantum computing,
Mm-hmm.
the unique capabilities of the Willow platform, and its potential to revolutionize AI across various industries. It's clear that we're on the verge of a truly transformative era in computing.
I couldn't agree more. It's been a privilege to share this journey of discovery with you.
And to our listeners, thank you for joining us on this deep dive into the world of Willow and its impact on AI. And don't forget, a brand new deep dive will be waiting for you tomorrow, exploring a completely different topic.
Until then, keep those minds curious.